So first, thank you for staying after the break and the pizza. That's always nice. So we're going to start first by asking every one of you to describe who you are, what you do, and what is your interest, and then we'll dive into the question.
I'm Vittorio Zoldan. I work in Amazon in the Artificial and General Intelligence Organization in Amazon. So it's the organization that built the NOVA models. I don't quite work on the model building, but I work on supporting businesses within Amazon that need to launch use cases with AI.
I'm Andreas Kollegger from Neo4j. Neo4j is a database company. I've been with Neo4j for quite a while at this point, first in core engineering, then in product for a while. So I've got my hands into both database engineering, but also things like language design, and now, of course, I'm involved with Gen AI and all that means for being a database, even existential questions of being a database.
I'm Lexy Kassan. I'm lead data and AI strategist at Databricks. We are a data and AI company platform for data intelligence. So if you haven't yet used Databricks, we're good. We're also hiring, see me after. And my role is I'm part of field engineering, so I'm out there talking with our customers. I primarily work with leadership on what their data and AI strategy is, how it's going to kind of manifest for the organization, bring change, what they're trying to do with that. I describe myself as a recovering data scientist. Thanks for the relapse, Louis, in those talks. So I'm typically not coding anymore, but my background was in stats, data science back in the way back days. That's where I came out from. So.
Cool. Okay, so I'm Rafael, currently a senior engineer at NVIDIA for deep learning algorithms, where I work specifically with billion-scale video generators, image generators, and LLMs. I'm also a final year independent PhD student doing neuro AI. So essentially, I take the learning from neuroscience to craft spiking neural networks, so which are a special kind of ANNs, to increase their computational power. So, and my background is also in robotics, so I spent a few years building robotic big systems using industrial arms, as well as a wheeled humanoid robot, and then a few years leading a team to build machine learning products at the British telco. So essentially, in short, I'm fascinated by the human brain, and I love building and commercializing autonomous systems.
Okay, actually, we'll start one question with you. Since you've made a choice to study spiking networks, right? Why did you go in that direction? Do you think that's where we should be looking at to find AGI?
Of course, but I'm biased. Like my PhD journey essentially started with me reading a bunch of neuroscience textbooks, so both computational neuroscience and molecular neuroscience, and that's how I kind of understood that there were gaps in how we implemented and conceptualized artificial neural networks compared to biological brains. And that's how I actually then looked for a supervisor and began my PhD 5 years ago. So even before neuro AI was coined. So I do think it's one of the possible paths to go to reach AGI. Because if we look at the biological brain, the human brain, it works strikingly in strikingly different ways as current AI models. And there's quite a few cognitive abilities that today's models are unable to actually cover. Like if we look at humans, we're really good at dealing with, well, some people, or most people, are really good with dealing with uncertainty, ambiguity, understand when we're missing information, or even when we have to adapt to a novel situation. And usually we even question why something is happening. And that's how we eventually derive laws of nature. And models cannot yet do this. Like even though some models, and especially GPT-type models, are probabilistic in some sense, they're able to entertain multiple possibilities, but not consider that what they have at their disposal, for instance, with tools currently, is insufficient to cope or perform a particular task. They don't know when they don't know something. We're able to some extent to do this. I think that's one of the core capabilities that we'll have to figure out.
Yes, actually, let's talk about graph a little bit, because this question is very important. Knowing when you don't know. Do you think that graphs can help us know when we don't know?
So that's an interesting question. So graphs can certainly, if you look at the topology of a graph, you can, visually, we again, back to your point about like how we process information ourselves and think ourselves. If you see a visualization of a graph, you'll identify gaps. You'll be like, oh, there's a gap here. It seems like something's missing here. And if you do things like link prediction, the whole idea of link prediction is, okay, I've seen patterns of how the graph grows, basically. I'm like, okay, this part of the graph hasn't grown in that particular way, so there's something missing there. You can apply that at many different levels of abstraction, depending on what you've represented inside of the graph. So I think that in sort of classical graph predictive terms, that you could do some of that. That a graph could help point out that you're missing some stuff. In fact, if I think about some of the, and I know that RAG is yesterday's news, like in some of the gaps in RAG, like that's actually what ends up occurring, is that like you get things that are similar to what was asked, but you don't know what was not asked. You don't know what's missing from what the user assumed, what they had in their intent that is missing, and that actually you can tell from doing a bit of sort of graph processing around the domain that the person asked about. So I think it is possible. It is a good complement, I suppose.
Vittorio, from your opinion, where should we be looking at? Do you think that graph is the answer? Spiking networks are the answer? Do you have your favorite path to AGI?
Well, I don't have favorite path to AGI. What I can do is just as a fanatic of the industry, reading and seeing what the researchers say. It seems like a lot of people are saying that neurosymbolic AI is needed for a certain type of reasoning, and maybe Rafael can tell us a little bit more about that. People think that that's internally what they're doing in OpenAI. Obviously, the path to AGI keeps being moved as a goalpost, and that's something that we have to first align, I think, in order to answer that question fully. But obviously, I'm not a researcher myself, so what I can do is form an opinion based on where the market is putting resources. It seems like a lot of it is in scaling the test time compute. I don't think it will get us the whole way, but it seems like we will get to a certain level where we will need an additional breakthrough.
Yeah, then Lexy, you coming from a company that has a lot of access to compute, right? Do you think that scaling will get us there?
Well, I mean, we sort of have a lot of access to compute. Like the compute that we run is in our customers' environments on their behalf. So we don't have any of their data. We don't have any of their compute. Like that's their own. Just to put that out there in case there are people who know and love Databricks, just so we're clear. I think with, what we're seeing though is not that our customers are trying to achieve AGI. If anything, they're trying to use agentic designs and small language models and smaller models in general to approximate the AGIs of what they actually want to do, which isn't everything, right? It's not as general as the true kind of AGI aspirations of some of the companies out there. And so what we're seeing isn't really the commercial viability right now of having a single model that is AGI. It's more saying we want a composition of a number of different capabilities that provide the general set of tasks, set of things that our company is trying to do to enable us to have a general intelligence for our company, not for like the grand universe. And that's something that we're helping our customers with today is, how do you start to, break apart the processes that you're doing, think differently about the tasks that you are trying to accomplish and what your company is really good at, and really make it into atomic composable pieces of tools that can then be reconfigured in a dynamic way by an AI that needs to accomplish something without being prescribed a specific workflow of tasks, right? Where an agent, normally when you think about an agent, it's like, oh, you do this thing and then that thing and then that thing. Well, you could code an API for that. Like, you don't need to have it as an agent.
Actually, that's an interesting question as well. I would like to get each one of you, what would be your definition of AGI? Because I think we've heard many of them and they don't always agree. So.
Okay, sure. Yeah, it's somewhat a difficult question in the sense that intelligence itself is hard to define. So one of the most common definitions has been that it's the ability to adapt to change. But we can actually look at artificial intelligence from a different angle. So it's really about two axes in my view. One is about the scale, that is competency over a set of cognitive skills, and the other is about the breadth, the range that the model is able to actually accommodate. And so if we take this two-dimensional space, AGI will be somewhere where it's able to cover almost all of the cognitive skills possible, and at a level that is equivalent to an individual human. Like, that is, it won't surpass a single person, but it will be as good as an expert person. Right.
Are you then agreeing with Sam Altman that is, to some extent, defining AGI by the number of jobs, of the percentage of jobs that those systems will be able to do?
Well, more or less. OpenAI released last year a classification for AI systems, which essentially starts, it's a 5-level classification, starts with conversational AI, which was the first level back in 2023 with ChatGPT. Then the second level is reasoners, where we got to last year, and the next level, agents. But we're not even there yet, because following the conception of this level 3 being agents, it's about agents that are able to operate on a user's behalf over several days. And current agents are unable to do this. And there are still two other levels that, just briefly, which are about innovators and organizations. And innovators are about having models that can go beyond their training data. That is, they can undertake some form of inventive creativity, which they are unable, and seems critical, because that's the only way that us humans have been able to discover new tools, discover the laws of nature, and so on. LLMs, GPT-type systems still like this, so we're not there yet.
Not there yet. We'll come back to that question, actually. Lexy, what would be your definition?
Goodness. I mean, to me, it's a system that can learn and can reason and can, I mean, yes, it goes beyond its programming, but I think that it's still something that can learn more types of things, right? And in a way, if you think about like some of the designs that we have today, the more data you put in, the more it learns. The question then becomes, how much do you let it learn on its own? And like, does it, the question that I always think about is like, does the system think when nobody's asking it anything? And that's right now is a no. Like, it's not learning anything new if you're not interacting with it. It's not getting any new inputs. It's not being pushed to respond. And really, it doesn't always learn much from the responses that it's giving and how you react. So how do we get to a point where a system can learn something new? Because if you're thinking about like what's so unique about humans and how we adapt to our environment, well, we're able to learn, we're able to grow. How does it grow? Is it curious? And the answer right now is no.
So I'll of course agree with both of you and all the things you've said so far. And I think this is a question of course, that comes up all the time. And it's clear just from asking the question that there isn't a good answer for it. It is as much a philosophical question as it is a technical question. And then on the technical side, you end up, kind of moving the goalposts, adjusting to like what it is you hope for AGI to be. And in what you're just saying there, I think part of where that overlap ends up then, having, not overlap, but the gap exists and will continue to exist, I think, for more than 10, 15 years. I don't know that we will solve it, is will agents ever have agency, for instance? Like, it's one thing for them to act and have behaviors that are complex behaviors and simulate complex behaviors. That's fantastic. But they don't have intent. They don't have goals of their own. They have somebody else outside of the system that's setting the goals and giving them direction. That doesn't mean that they can't be very rich and complex and autonomous, but that is certainly one of the gaps that I would draw for at least, I don't know if it's AGI, but for some level of intelligence, and then the behaviors, the very complex behaviors that we see today. And yet, within that, as some of the conversations I had during the break, there's a sliding scale where it's a false choice. Like, kind of who cares? Like, it's doing incredibly complex behaviors that are useful, but perhaps not yet predictable. And that's really the challenge technically that we need to solve, is not, hey, it's doing really interesting things, but it's doing things in a way that we're willing to trust the decisions that it makes for like meaningful outcomes, not just, hey, I've generated a really great marketing email, but hey, I made a life decision for somebody. We're not close to that. And that's a bar that's way up high, but there are many bars that are lower than that are very useful, meaningful, complex, but maybe not exactly intelligent. And I'll go all the way to a pop culture reference here, like, in Westworld, okay, they clearly crossed the threshold where they were conscious, they weren't just following their dialogue trees and, kind of being automatons. They were beings at some point. But prior to that, they were just following a script, and yet within the script, they were incredibly complex behaviors. We're gonna see a lot of that will be really entertaining and very useful, but not something you wanna trust for, spending your dollars yet.
I think to answer this question, I obviously agree with a few points. I think we have to distinguish between what is sentience and what is AGI, just general intelligence, because you can have hugely intelligent systems without having sentience. And I think that putting metrics or goalposts based on the values that it demonstrates, such as, for example, curiosity that you were saying, is more on the sentience part, more than the intelligence, I would say. I agree with the definition of AGI being a system that can automate, that can perform economically viable work, and that was the original OpenAI definition, which now has become a definition that is based on the output. I mean, it's still based on output if it's economically viable work or if it's 100 billion in profits, I believe it's right now. But that is purely a legal definition because of OpenAI, because they have an agreement with basically on who owns the use of a model created by OpenAI once it reaches AGI. And in order to have more funding from Microsoft, they need to move that goalpost a little bit more to make sure that Microsoft still gives money. Well, I mean, it's not my novel interpretation. Obviously, there's people that describe exactly this. So to answer your question, I do believe that it should be based on outputs. It shouldn't be based on inputs on a technical description of it, because it's kind of counterproductive if you do. It's you want product metrics instead of having technical metrics to judge a customer experience. So it has to be based on what it actually can deliver, not necessarily what is going on inside the head if it doesn't actually perform the tasks.
That's very interesting, and this makes me think about the training data, because you've probably, like me, read the papers around R1, what O1 might be, what O3 might be. And the reinforcement learning stage, when they talk about the data, they never talk about data related to emotions. It's always hard math, hard science. I'm not absolutely sure that someone could work in this company while being a sociopath or a psychopath. And it looks like you could be AGI and be a sociopath or a psychopath. What do you have to say about that? Lexy, I
I
think
guess I'll
that's a
take
question
it.
for you.
Okay, I'll take that one. So, this is a very philosophical question, but it's, how do you define truth? Like, just because there's a scientific paper on something doesn't make it 100% perfectly accurate representation of the world, right? We've seen this forever. We continue to see it. This, just because we have a mathematical model of something doesn't make it like unshakable forever. That's why we have science. Still, we're all, this is the data science festival. Yes, and string theory. So, these are if you just throw things at a model that are the current understanding or whatever has been studied, which is really what it comes down to, you get only the things we know today and in the way that it's been funded and researched and biased and I used to be the founder and host of the Data Science Ethics podcast. This was before we were talking about generative AI. This was like 7 years ago. So it was just slightly before Cambridge Analytica. And these are things that we've been dealing with forever. So the training data for these things is going to be biased, right? There's bias in all data. Like, don't get me started on that. But if you want to really have something that's going to create something that's less biased and that will show emotion, you have to provide inputs of that. You have to create a data set that models the world you want to see, not the world that has been, which is a very different ask. And it kind of brings me back to like the question of requirements, right? Like, this is the Data Science Festival. How many of you are data scientists or recovering data scientists? Somewhere in there. Okay. How many of you have gotten good requirements the first time someone asked you to do something? Okay. And there we go. Like, this is the fundamental problem. Like, we have to deal with what is it we're actually trying to solve for and what data is needed to solve for that, not what data is available because it was easy or we could scrape Reddit or whatever. Like, how do we get to a vision of what we want in that data set, not what was easy?
Anyone else want to try tackle this one? Okay, that's fine. I understand.
Oh gosh. Apparently I've just scared them into silence.
So, another scary question, and maybe I'll start with you this time. Do you believe that we will notice when AGI is here? If there is no press release, let's say that R3 and O4 are released. Are you sure you will be able to tell, actually, this is AGI?
I don't think that, well, obviously, it all depends from the definition again, right? So that is we didn't agree on the definition. So if it's based on outputs, that definition is when you achieve it, right? So if it actually is able to perform at the level at the benchmarks that you have set, ARC AGI benchmark, for example, people had it as a benchmark for AGI, and now that O3 has got I believe like 76, 81% score on that. People are noticing that actually, you can actually cheat that benchmark a little bit more, and you can train on the test data or the public data and fine tune it a little bit. So I think that we will not ever reach a point in which we will say, this is, no, I shouldn't be doing that prediction at all. I should be saying that the goalpost will continue to move past until, looking backwards, we probably have a model that has performed and automated all the economically viable tasks that it could a couple of models back, but it's still not really going to be considered full AGI, and that's where you get into the different answers of does it have to come with conscious sentience? It does not. I don't believe that it has to at all, because it doesn't have to have those emotions, has those values to to be intelligent, and you can see it with the human intelligence spectrum as well. So the answer to that is we will probably figure it out a couple of iterations after it actually has.
I'm going to push back a little bit on the sentience question, and acknowledging that I don't know, but I wonder that some level of intelligence requires sentience and requires curiosity, that without that component, however that component is expressed, that'll be a hard limit for what's possible. That said, like for the original question about like will we know, I think we will. There'll be AGI will have its ChatGPT moment. Somebody will release something, they're like, oh, this is really good, let's get it out there and see what people think, and everyone's minds are going to be blown. The way we kind of really haven't since the initial explosion around ChatGPT. There's been great advances, impressive advances, but nothing that has really been as big of a step change as pre and post the ChatGPT moment. So I think we will notice, but it's going to be, we don't know what it'll be. The goalposts in some way will be defined by that moment. Like, oh yeah, oh my God, whatever the hell that's doing, that is AGI. We'll experience that huge leap forward. And then until then, the progression, it'll be hard to notice. And I don't think we're going to progress our way there. I think it'll be a step change. I'm a developer, not a data scientist, so, the hell do I know? Oh, wait, sorry.
Yeah, again, just to push back something very small, is that we currently don't know if we're actually able to decouple sentience from intelligence when we reach a certain point. So that's unknown. And even if we think about curiosity, I mean, one facet of curiosity is simply being hypothesis-driven. Even coming up with an hypothesis requires some degree of curiosity. Okay, in terms of whether we'll be able to notice when AGI comes or appears, I think the only way we wouldn't is if someone develops AGI by themselves in isolation and doesn't apply it for anything. So I don't think that will happen. We'll notice AGI when it comes. The question is, how long after? Like, it's not, will we detect AGI the moment it really appears, or years, decades after?
So let me push back on your pushback a little bit.
A counter pushback?
When basically the new models are coming, every time we rate them, we have benchmark, we evaluate them. But those are benchmarks that we've created ourselves. Is it possible that those models reach a level where we cannot tell the difference between the model that is just below AGI and the models that has passed it, because we don't have the cognitive skills to evaluate the value of the output that you are talking about? Is that an hypothesis that makes sense from your point of view?
Yeah, but I think when we reach that point, it will become very difficult. Because it's already quite difficult to craft a benchmark that will properly measure AGI, because as soon as the benchmark is released, someone will game the benchmark. We've seen it with the frontier models. It happens all the time. However, there are some, like even this month actually, a new benchmark was released called Humanity's Last Exam. It's composed of 1,000 problems that are very difficult. I mean, I wouldn't be able to solve probably not even 10% of the examples. I went through them. It requires domain expertise that very few people actually have, or even have access to the data needed to understand and solve the problem in the first place. So yeah, it will be difficult to, increasingly difficult to come up with new benchmarks that will properly measure it. And the other aspect is it will be even more difficult to ensure that there wasn't data contamination. Like on the era of internet scale data sets, like it's very difficult to enforce no contamination of the test data in the training set. And yeah, unless all the companies open their data, or at least showcase how they trained the model with specific data set and it was able to generalize beyond that data set, I don't think anyone can claim that they've reached AGI. Unless, as Vittorio was saying, we look at an output measure. Like if, again, some model is able to generate $100 billion in profit, we could easily argue, okay, it's AGI. But we'll see.
Interesting, interesting hypothesis. Lexy, one question to you. Do you think that we are going in the right direction? Meaning, do you think that LLM might get us there? Or do you think that we will reach the limit of LLMs sooner or later?
I think we will definitely reach the limit of LLMs. I mean, LLMs are at their core a probabilistic mechanism for predicting words. Yes, they're getting better at doing some determination of why did you pick this word, but it's not necessarily reasoning in the same way without other things being put into the mix, right? This is why we're seeing multimodal capabilities. This is why we're seeing different kinds of tools being put into the models so that they can have things like a calculator. Like these are not complex. And so I think that we've already, to a great degree, reached the limit of what LLMs can be doing for us without other things in the mix. So yeah, I think we're there.
I like your calculator example because I was talking to my daughter about R1 and I was showing her that it's making mistakes in basic calculations and she told me, but Daddy, that can't be AGI if it can't count. And
This is why I like
She
agents.
probably has a better definition of AGI than any of us have.
okay, in terms of the ethics of AGI, what do you think we need to get ourselves ready for? And actually, that's a question for each one of you, because I don't think that's a question that should be dealt with by ethicists only. I think we all have to think about that.
You want to answer last? So,
Whatever.
So one thing that really strikes me is how underprepared the educational industry is for educating people that have a job displacement. Universities are used to taking blank slate students and converting them into professionals that can do a particular job, but it's a very different problem to solve if you have to at scale convert people that have one type of skill set into a completely new one that is future-proof. And there's not much going on about that. I don't see educational institutions really stepping up to do that. And obviously we'll need, basically as a definition of this problem, you have a lot of different starting points. Therefore you need personalized education for each one of them. So it's going to be enabled by AI in itself. But that is definitely something that I would like to see a lot more work than is currently being done, because it's going to happen. Obviously, it's one of the most predictable outcomes of AI, even non-AGI. Obviously, just talking realistically about the models that we currently have is just that they are not in the workplace yet, and they're not integrated with the tools that we currently use. But a large percentage of the jobs already can be done. How do you reskill those workers to something else at scale?
I can't wait to hear your answer.
Oh gosh.
So I like all of that, and I think I'll go actually back to like what you were saying earlier, like before the ethics question. I think a lot of the ethics, the easiest way to address it is to not be worry about actual ethical questions, but to worry about, do you have guardrails in place? Do you have auditability? So you have traceability, observability, so you know what the heck's going on with the system. So that when something goes wrong, you can be able to trace back and figure out what went wrong and try to put in more guardrails to stop that from happening again. Along the way, some unfortunate things are gonna happen if we're gonna continue to make advances and continue to kind of test the edges. We, I think, as an industry already have some habit for doing that. We're all being very careful about at least doing evaluation to see that the answers are right or wrong. That's a good first step. But then past that, as we give more actually access, I guess I'll say, to now I'll say agent systems, so that they're not just working to answer a question, but they're actually acting on our behalf. Exactly the point that that happens, you're definitely going to want to have some very clear guardrails in place. We're like, okay, I'm only going to give you a budget of $100. Go wild, spend that however you want to, trying to achieve the goal I want, which is to get a great dinner prepared for me or whatever it might be. But like you're going to have some, as a person interacting with the system, you're going to have the option of being able to give very good guardrails yourself on the system that you're using. So it's not just us, the providers, the builders, that are going to put in some guardrails for trying to eliminate hallucination and trying to eliminate some biases and things, but that's going to go all the way to the end user, that the end user is not going to blindly use these things. You're going to want to be able to set some parameters yourself, and over time maybe gain more trust, but that's going to take some time. But I think along the way there's always going to be a very system of rules keeping everything boxed in, and that's our obligation as builders, is to enable that.
Well, in addition to all of that, I think putting in place measures to protect essentially the privacy of data, because when we have models that are end user facing, that are interacting with people, even with children, we have to ensure not only that the data that those models have access to are actually extracting doesn't get used for nefarious reasons or even lost, because any company that is offering, let's say, an AI assistant for kids, an AI tutor, will have a lot of data that will be sensitive, and they can open themselves to attacks. And so the question of data security and security in general is very important. The other aspect is also we need transparency over the behaviors that were instilled in these models. If we have an AI tutor, we have to make sure that what the model is teaching actually helps kids, helps them over time. It's not about simply helping them solve a problem, but also the kind of, let's say, ideas they're sharing or, let's say, forcing into kids. So I think we have to be a bit careful there, ensure that there are domain experts such as psychologists behind the scenes that do accompany and the conversations that happen, the interactions, to ensure that everything is done in a very protective way.
So I think that we've been talking about a lot of the types of ethical concerns that are coming up now in the context of sci-fi for decades, really. Like these are things that have been thought about. Like if you've ever watched Black Mirror, or I'm a big Trekkie, so if you ever watched Star Trek, TNG, Picard is my captain. Some of these things have been thought about, and there isn't a great answer, and there isn't a universal answer. And that's like the unfortunate truth is that if we go around the room today, there are going to be some things that we probably commonly would agree on, and there are going to be a lot of things we don't from an ethical standpoint. So if we as practitioners encode ethics into a system, that doesn't make it right for everyone. The data doesn't make it right for everyone, right? So these AGI kinds of systems, if they're universally applied, it's like saying that you're training your data, your model on one population and applying it to another. And we know how that goes, right? From, again, this is some extrapolation from a lot of stuff we've been doing for a long time. So I think that we really need to think very carefully about how and where we apply different kinds of intelligences, and be willing to say no to certain things. We've already seen some pretty drastic ramifications of AIs being used in situations they were not prepared for, and it's led to outcomes like suicide. Like these are things that have already happened, and they are now in litigation because of them, right? This is not a like, oh, someone might get the wrong answer on a math test. These are some actual life and death potential consequences. And when you think about the ethical ramifications of using AGI and saying, well, I'm going to program in what I want for my objective. Like it's like treating it like a wish spell if you're a D&D nerd like me, or a wish from a genie, right? Be very careful what you wish for. I was having a conversation about a year ago with some folks from the Ministry of Defense, and I was there just kind of listening in on what they were talking about. We were at a data governance conference of all things. And they were asking about, ethical AI and how do we do this? And I'm like, well, there are certain areas where you have to be really careful about, think about who your stakeholders are and so forth. And then I saw where they were from. I'm like, you have a very clear definition of who your stakeholders are and who they aren't, because you're the Ministry of Defense for this country, not all the other ones. So which people matter when you say you're human-centric? Oh, the ones we defend. Those types of decisions have massive ramifications. And we need to be very cognizant that even the things that we put into, my phone just off, public use and that are being used not in things like defense, but in normal day-to-day applications can still have these ramifications and are today, even without AGI. So how do we start to look at encoding ethics into that? How do we look at putting in place guardrails when it's not like, oh, whoopsies, we gave the wrong answer. Someone died because we didn't put in an appropriate guardrail. Like, that is a horrifying and very humanizing way to think about this, right? Like, back in the ML days, you knew the specific question you're answering. In a generative world, you can generate all kinds of different things. How do you know it's not going to add up to something terrible? What guardrail do you put in place for the next incremental answer? That's the big question that I think we need to get at. Is it's not how can we have an agent that acts over a multitude of days. It's how do we ensure you don't have radicalization over a multitude of days? How do you ensure you don't have an increasing progression of depression in someone over a multitude of days, right? Think about the inverse, because I guarantee you someone else will, and they're going to use it against others. There are bad actors out there, there are nefarious things, and whether we do it by accident or incident, these things do happen.
And so here, you're insisting on the almost individual or, let's say, population, country level risk. But do you think, like some founders of the AI field, that there is also a humanity risk, humanity as a whole, as opposed to individuals being put at risk by AI?
I think it depends on what risks we're talking about. And I don't think that it's a country level question. Because, I mean, look around the room. We're all in the same country currently. Do we all have the same background in ethics? Like, do we all believe that the current administration is going to know exactly what we want an AI to do? Probably not. And we're all in the same field, for goodness sake. This isn't something that we can solve once and for everyone. I do think that there are some guardrails, and obviously countries are making regulations around some of this to try to curb what's going on, and to try to put some guardrails on it. But it's very sparse right now in that regard.
And maybe for Rafael. Rafael, do you think we will find algorithmic answers to those problems? There is this field, for example, of mechanistic interpretability that people are very excited about. Do you think that this is where the answer is going to come from?
Personally, I don't think so. Because at a certain moment, the scale of dimensional models will be so big that even applying those kinds of model techniques and approaches to inspect the inner workings of a model won't actually lead us to understanding why they arrived at a particular output or conclusion. Because usually those approaches are looking at the salient features, and so looking at what contributed the most towards a particular output. But in reality, we might also have to look at the omissions, that is the features that were silenced or inhibited, because it's as much as what gets added as what gets subtracted. Like if we're looking at the activations, all the operations, and it's almost trying to reverse engineer the brain by looking at patterns of activities while knowing all the synaptic connections. We don't know what kind of software the brain is actually running. In the same way, we don't know the actual algorithm that the model has learned and is actually applying the operations. Right? We're trying to imbue some meaning where there's uncertainty about what exactly is being computed within the model. Like even if we take current GPT-type systems that are operating at a token level, we don't actually know if they're retaining the same meaning as the original tokens in the computations they're performing. So I think it will be a very challenging and difficult task. That doesn't mean that we cannot use mech-interp currently to understand a bit better why LLMs are performing the way they do and try to correct maybe or further align their outputs, their predictions.
Just one thing on what you are mentioning. There was a very interesting research by Apollo Research recently that showed that one model, when he was interacted with and someone told him that he was going to be deprecated, he tried to copy itself on another machine, pretended to be the other model that was a little bit dumber. So when we are talking about sentience, about intelligence, I think we are starting to see some sign of this. But interestingly, because we now have the chain of thought of the model, we can at least read what it was trying to do. So that's interesting. Maybe we'll take
Just on that, like the first point is, sorry, about the Apollo research. Sorry, can you repeat again that initial bit?
So basically the model tried to copy itself
Right.
to another
I think
machine.
I've read that story somewhere, or that movie. What I'm trying to say is there's a lot of references already in training data to those kinds of behaviors. And these are very powerful imitators, but they're still not generally intelligent tools that have their own goals and purpose. They're simply imitating what they've seen. And we've seen a lot of sci-fi stories performing just that. And that's
not
what
a good
I
sign.
think.
There was a Star Trek TNG
doesn't end well.
episode on that.
Maybe we'll take some questions from the public now. Ooh. Okay.
Yeah, we can do that. We can do that one, Louis. Maybe if you could nip in there. I'm just going to say as well, Louis, I suspect it might have to be rapid fire because Layla can run over timescale. So we've got maybe 5 minutes.
Okay, rapid fire, so me speaking quickly. So, a well-known gauge of AGI, or at least a computational system exhibiting some sort of human-level intelligence, is of course the Turing test. There's a strong argument saying the Turing test was actually passed in the 1980s, when a system decided to, well, you'd ask it something and it would respond by insulting you. And your response was to get very angry, and its response would insult you in even more sterner terms, etc. And you get so worked up, etc., that, yeah, you'd believe the person at the other end wasn't in person. So this raises questions. Okay, so if getting somebody very emotional plays a heavy role in something seeming intelligent, surely emotion should play a role in definition of AGI. And you know, to what extent is that true, not true?
Well, emotion is one of the facets of intelligence. I mean, there's emotional intelligence that we've now started paying a bit more attention to it. So when we come back to the definition of AGI or artificial intelligence in that sense, emotion is one of the facets that they have to learn. And social cognition, is quite important for all human interactions and to operate within our societies. And those artificial systems have to be specialized and tailored for our societies, not some other society. So I do think it will play an important part. Yeah.
Just based on that, emotion is definitely a critical part of human intelligence, but that's because human evolution has made the brain so that having emotions was necessary for human interaction. But why would you need to hold a system that doesn't need that in any way? It doesn't need human interaction it doesn't need to perform, because it doesn't need to form social bonds. Why does it have to be held the same? Why do you have to be prescriptive with that requirement in order to judge whether it was actually intelligent at delivering the tasks that it had to deliver?
Maybe we'll take a quick rapid fire question, maybe faster than the previous one.
Sorry, you've been talking about AGI, but I don't think we've actually agreed on what intelligence is. I'm kind of talking about the Francois Chollet paper on the measure of intelligence. So we can't really agree on what intelligence is, let alone AGI. So what can you say about that?
Maybe I'll take this one quickly because from the ARC challenge, for me, when I look at the test, it looks like if an entity was intelligent and let's say AGI level intelligent, it would be able to do that, but that wouldn't, for me, qualify it as AGI at all. So it would be included in the test, but it wouldn't be the whole test. So that's my perspective on that.
Yeah, I think we can come back to taking the definition. And first, yes, there's a lot of different opinions in terms of how to define intelligence. But if we take the most popular one as being the ability to adapt to change and look at a benchmark like ARC AGI, it actually requires, assuming that the model hasn't been exposed to the benchmark data, it actually requires said model to adapt to novel situations. Like all the problems don't implement the same logical rules. They require different understandings, different let's say understandings of the semantics of the dynamics that are happening within the transitions of the 2D grids that they're facing. And I think at that point, models that are able to fulfill and adapt and solve a different number of tasks of different nature will at a certain point indicate intelligence.
Maybe one last question.
One over here, Louis. This man. Are we ready? Ready?
Really?
That was easy. I have to stand up.
So, I did a bit of coaching with the data scientists over at Amazon side, and one of the biggest things with Gen AI coming in was that they were moving away from multimodal sort of structured multimodal builds and focusing just on building up their Gen AI function. And that led me to a question, part of my master's thesis actually, which is, do you guys believe that Gen AI should be standalone, or like humans should be multimodal, where Gen AI is the core and they know where to reference, like a library, to bring in that expertise? And do you think that would be the next level of agentic, agentic design, agentic use, where we're not relying on one model to actually know everything, but to know where to go to get everything and answer the most basic questions?
Yeah, quick one, and then I'll pass it to you. I think it would be the actual inverse. Like having a core reasoning model that will make use of different Gen AI models that are specific different modalities, because they'll act as interfaces for such modalities. If we look at the human brain, that's actually how it happens, right? Sure.
I think we're already there. So, I mean, today we have, like, customers of Databricks are using Gen AI as a routing agent to then call other tools that may or may not be Gen AI. They might be machine learning, they might be text to SQL, or they might be, calling other agents in other systems. We have this today. So, I think that there's a lot of reason to believe that as we continue to grow out agentic designs and networks and really break down the tasks that we're trying to accomplish into like really atomic pieces, that you'll have the tools necessary to kind of, again, a facsimile of AGI that is composed of a lot of like very unique tasks that are specialized and very like domain expert.
Okay, then to conclude, I will ask each one of you a date, as you expected before coming. So, what's your date for AGI?
I don't think I can give one. I'll just copycat what I see. The last time that I saw a survey like that, they agreed on before 2030 being the I think more than 45% of participants answer that, of researchers. So before 2030.
Okay. Andreas? 10 o'clock?
I'm going to go with 8:52 in 2031. It's going to take a little bit longer. On January 28th, sorry. Yeah.
See a gambler.
I'm going to go with fake GI today and true AGI sometime after we define what the heck it would be.
I mean, look, even NVIDIA CEO came out and said that even hallucinations will take a few years. So figure out how to solve hallucinations is simply one of the stepping stones into achieving a more generally intelligent tool. So I think it will take more than that. I don't think before 2030 we'll attain AGI, but it's okay, it doesn't matter because, I mean, the transformer architecture sparked real breakthroughs. And so both GPT-type systems, world foundation models, and now agents have tremendous potential for enterprise. And it's about artists, workers, and companies capitalizing now on this to unlock said potential. So it's fine that AGI won't arrive tomorrow because we have a lot to do before then.
Thank you very much. So thank you for coming. We had a great time talking with you, and we keep in touch, and thanks to Data Idol and Digitas for organizing this.